For the rest of this week, we're going to look at three exponential properties. The first is the product rule, and today's target is I can simplify an exponential expression using the product rule. The reason why we do these things is in some fields, scientists and people who use very large numbers or very long decimals do not want to use them in multiplication division problems. They want to find shortcuts around it and also find shortcuts of writing those numbers. And that's one of the reasons why we're going to learn these rules before we actually apply them to those problems. The first of our exponential properties is called the product rule. And we use this on exponents that we're multiplying together, and especially if they have similar bases like these two do. I'm going to use variables for my bases rather than numbers because variables, you don't have that need to raise them to a power at this point. And we can still say what the exponents mean and find a shortcut to this rule. There is a shortcut to this product rule, but I want to show you why there's a shortcut to it first. Here's our first example. This is our simple problem. It's x to the fourth power times x to the second power. Well, x to the fourth power really means we're multiplying that variable 4 times a multiplication problem, 1, 2, 3, 4. Well, there's our x to the fourth power. It's x times x times x times x. I'm going to bring down my multiplication symbol here. And then x to the second power really is just x times x. Well, if we look at this, and we're trying to simplify this, but we're not trying to evaluate, we're just trying to rewrite it with a base and exponent. Think about this. How many times are we really multiplying by x throughout this problem? Because this is one big multiplication problem. Well, we have 1, 2, 3, 4, 5, 6. So our base is still the same. It's still just x, whatever number that is. But the number of x's on our problem now is 6. So x to the fourth power times x to the second power is really x to the sixth power. It's really we're multiplying 6 x's together. And that's basically the theory behind the product rule. Here's our second example. It's a to the fifth power times a to the third power. Remember, all this exponent's saying is how many of these a's are in a multiplication problem. So we're going to write down 5 a's here, because it's saying we're multiplying 5 a's in a multiplication problem. We bring down our multiplication symbol here. How many a's are we multiplying here? Well, according to our exponent, 3 of them. Well, think about this. We're multiplying 5 a's here, another 3 a's here, and we're multiplying all together. How many a's are we really multiplying together? Well, you probably already guessed it, but we're multiplying 8 a's together. Now this time I want to have you see something. You can always rewind back and look at our last example and see if this is true there. Look at our exponents here. You had 5 a's, 3 a's. What can you do to 5 and 3 to make 8? Add them. So we could add these two together and get 8. On our last example, we had a 4 and a 2. Well, our answer is x to the sixth power. Well, what can we do to 4 and 2 to get 6? We add them. That is the pattern on the product rule. It's actually that simple. Your simplest problems on the product rule are these types of problems where you're just adding together your exponents and keeping the base. So let me show you what the product rule really is, and then we'll look at some different examples of what happens maybe when something comes up that you're not prepared for. And here's our basic rule for the product rule. Now I replaced our exponents with variables as well just to say what we're going to do with those exponents. But if you notice, if your two bases are the same, what you can do is basically add your exponents together and keep the base, and you'll have a simplified answer for that problem. A lot of people who use this so they don't have to write a big number down and multiply two large numbers. No one wants to multiply something in the millions by something in the hundred thousands. So what they do is they try to figure out ways to get around that, and this is one of the ways they can get around it. And we'll see more of this next week when we deal with something called scientific notation, where this rule will come up next week. Here's our next example. Our next example, actually, we still have a positive exponent here, but look over here. We have a negative exponent. Well, if we apply that product rule to this problem, we notice that the bases are the same, so we know it's going to be y to something. But the second, that second part of the rule is add your two exponents together. So if we added 4 and -3, what we would have to do is this. And for those of you in my 2nd through 7th period classes, look what we have here. We have 4 plus a -3. Well, if we go back to what we were doing before the break, remember what I told you. We just have a 4 in the front. And since we have these parentheses around that -3, positive times a negative, well, that makes a negative. And we just bring our 3 down. So really our problem we're doing is right here. 4 positive, 3 negative, or if you look at it carefully, it's really 4 minus 3, and 4 minus 3, or take away 3 from it, you get 1. So our answer here is y to the first power. Now when you have positive and negative like this, you're probably going to have to subtract the two numbers. And keep in mind, which one's bigger? Is the 3 bigger or the 4 bigger? Well, in this case, since the 4 is bigger, we just leave it as a positive 1, just a whole 1. So this is where our integer rules for adding comes into effect. That's why I had to really drill and kill that last week before fall break. This is where it's going to come up mostly this year, is in these types of problems as well as some other problems later in the year. Let's look at another example. Here's our next example. It's c to the -7 power times c to the 4th power. Well, since our base is the same, it's both c, we're going to go ahead and say our base is going to remain a c. It's not going to change at all. What we have to do now is, since the bases are the same, we're multiplying, we're going to add our exponents together. So we have a -7 plus a 4. Well, remember what we talked about the week before fall break. Which one do we have more of? Well, obviously we have more negatives. And how many more negatives do we have? Well, you can subtract the two numbers and figure that out. 7 minus 4 is 3. So these become c to the -3 power, but there's a slight catch when you have a negative exponent at the end. And the catch is when you simplify, you really can't leave that as a negative exponent. So we have to bring back our negative exponent rule from yesterday to deal with this thing. And if you remember from yesterday, whenever you have a negative exponent, you're going to essentially flip it, because right now it's really over 1. And so what you're going to do is you're going to put a 1 in the numerator, fraction line, and you're going to bring this into the denominator and take off the negative. And really your simplified answer is going to be some sort of fraction or decimal. And this right here is your simplified answer. So when you have this little negative exponent come up, you're going to have to flip it down. You're going to have to move it into the denominator. And here's another example. Now we have m to the -10 power times m to the -4th power. Well, since our m's are the same, we're going to go ahead and keep the base, because that's not going to change in this case. But look at our exponents. We're going to add them together, so that really means you're going to take a -10 and you're going to add it to a -4. Now some people can look at this and already say, okay, I know what the answer is. It's going to be, negative plus a negative makes what looks like a larger negative. But to make sure we see that for sure, same thing here. We have negatives on this side and negatives on that side. Well, you have nothing but negatives, so you're going to add those negatives together and get your -14. But like in our last example, we can't leave this as a negative exponent. So to finish this process off, we're going to put a 1 on top and move our exponent in its base into the denominator and take off the negative. And really what we have here is what could be a very small number. Now this is what you got to watch out for, because there's times you can't use the product rule. Remember, the product rule can only be used when we're multiplying two terms together. Well, look what we have in the middle here. We have an addition sign. So that means we're multiplying 3 x's together on one side and only 2 x's on the other side. But here's our problem. Our problem is, are we multiplying all this together? No, we're adding them together. The product rule won't work here because in order for it to work, we have to have a multiplication sign between our bases here, our like bases. We don't have that here. So our simplified answer for this problem is actually what you started with. You can't do anything else to it. Not until you know what x is, and then maybe you can evaluate it if they want you to evaluate it. But this is pretty much where the product rule stops. It stops on when you add a base, 2 bases together, and when you subtract 2 bases together. Think of a plus or minus sign as almost like a wall. And it's basically saying, no, product rule won't work here. You can't do it here. You know, this is something completely different. You're probably going to have to know what x is to even evaluate it. You can't simplify it the way it's written right now. Plus and minuses are basically dividing points. They just create a wall and barrier to keep you from doing these types of rules that we're going to be talking about in the next few days. And remember, today's lesson was I can simplify exponential expressions using the product rule, which means if your bases are the same, what you're going to, in an exponential expression, that means you're multiplying, there's 2 bases, same bases, different exponents, or it could be same exponents. It's just the idea that you keep the base, because that's really what you're multiplying by, and to see what you're multiplying by, in the end, how many x's there are, just add your exponents and you're good to go. We're about to do example problems and practice problems, and some of them will have numerals and not variables in it, but we're just going to simplify today. I don't want you to get simplification and evaluation confused, because I really want you to master this first before I even ask you to evaluate anything. I hope you found this lesson helpful. You can always go back to it on the website. It's knowme.com. As soon as you get your login information, you can always go back and watch any lesson you want that I happen to post up. I hope you have a good day.